ሄሎ ተማሪዎች እንዴት ናችሁ? ሰላማችሁ ይብዛ። ሽብሩ ቲቻ ነኝ ከሽብሩ ቲቻ ኦፊሻል ዩቲዩብ ቻናል። ዛሬ አንድ ቶፒክ ይዤ መጥቻለሁ። እሱም ስለ ኬሚካል ቦንዲንግ ቲዮሪስ ነው። የቶፒክ ግሬድ 11 ኬሚስትሪ ቴክስት ቡክ ዩኒት 2 ላይ ይገኛል። ስለዚህ ይህንን ቪዲዮ ከቴክስት ቡካችሁ ጋር ኮምፔር እንድታደርጉ በአክብሮት ጠይቃችኋለሁ። ይህንን እያልኩ ቀጥታ ወደ ዛሬው ቪዲዮ እንሂድ። ለኢንትሮዳክሽን እንዲሆንልን ኬሚካል ቦንዲንግ ቲዮሪስ ከማየታችን በፊት ሁለት ሜን ቶፒኮች ለማየት እንሞክራለን። አንደኛ ስለ ሊውስ ስትራክቸር and its limitation፣ ሁለተኛ ደግሞ ስለ ቫላንስ ሼል ኤሌክትሮን ፔር ሪፐልሽን ቲዮሪ እና ሊሚቴሽን ኦፍ ቫላንስ ሼል ኤሌክትሮን ፔር ሪፐልሽን ቲዮሪ ዲስከስ እናደርጋለን። let us start from the Lewis structure, or we can say Lewis model. This Lewis structure is one of the earliest models that explain the formation of covalent bond between two atoms. ይሄ ማለት ነው covalent bond formation between atoms explain ለማድረግ or understand ለማድረግ ብዙ ቲዮሪዎች፣ ብዙ ሞዴሎች፣ ብዙ ስትራክቸሮች በዲፈረንት ኬሚስቶች ዲቨሎፕድ ሆነዋል። ከነዚህ ሁሉ ሊውስ ስትራክቸር or the one which we call Lewis model የመጀመሪያው ነው። የማለት ቫላንስ ሼል ኤሌክትሮን ፔር ሪፐልሽን ቲዮሪ፣ ባላንስ ቦንድ ቲዮሪ፣ ሞለኪውላር ኦርቢታል ቲዮሪ are developed after Lewis structure or after Lewis model. Again, in Lewis structure, chemical bond is represented by electron dot structure or electron dot formula. Again, valence electron is represented by the dot around centrality. This is the main idea which are present in Lewis structure. Then in Lewis structure, there is this Lewis structure fails to explain the formation of chemical bonds. Again, the Lewis structure has no idea about the shapes of the atomic molecules. Those are the main limitations of Lewis structure. Next, let us start valence shell electron pair repulsion theory. Here, in valence shell electron pair repulsion theory, molecular geometry of the molecule is predicted based on the repulsion between the pair of the electron which is present on central atom. Here in valence shell electron pair repulsion theory, pair of electrons on the central atoms are arranged to minimize the repulsion among them. Again, this valence shell electron pair repulsion has its own limitation. This theory gives geometry of simple molecules, but practically does not explain them. Explain ቢያደርግም ራሱ the limitation, that's a limited application. So because of the limitation of Lewis structure, valence shell electron pair repulsion theory, modern chemical bonding theories are developed to explain the formation of covalent bonds between atoms more accurately. So let us proceed to modern chemical bonding theory. Modern chemical bonding theories are classified into two: one valence bond theory, second molecular orbital theory. Valence bond theory, electrons in the molecule occupy atomic orbital of individual atoms. Atomic orbital of the individual atoms which is present in molecule is occupy the electron, which means we now the individual atoms which take part in covalent bond formation in valence bond theory. since valence bond theory gives us a picture of individual atoms which take part in covalent bond formation between atoms. Okay, next, what is the key idea of valence bond theory? The key idea of valence bond theory is covalent bond is formed when the orbital of two atoms overlap. Yeah, this is a key idea of valence bond theory. ማለት two atoms overlap ሲያደርጉ covalent bond between two atoms ይፈጠራል የሚል ጽንሰ ሐሳብ ነው valence bond theory የያዘው ማለት ነው። That overlapped region is found between two nuclei, and that overlapped region is occupied by the pair of the electron. What do you mean the overlapped region? Overlapped region is the two orbitals which share a common region in space. We call it overlapped region ብለን ነው የምንጠራው። Okay, next, why valence bond theory is useful? Specifically, why valence bond theory is useful over this structure? Why it is useful over valence shell electron pair repulsion theory? እዚህ ጋር ደግሞ ለምንድነው ካልሽ structure valence bond theory formation of covalent bond explain ለማድረግ why it is useful over valence shell electron pair repulsion theory, why valence bond theory is useful የሚል እናል። Here valence bond theory help us to explain definition of covalent bond, why covalent bond is formed, how covalent bond is formed. We can explain by using valence bond theory. Also, we can explain the strength of the bond by using the principle which are present in valence bond theory. Again, we can explain how the molecular shape arises from the interaction of atomic orbital by using valence bond theory. That is why valence bond theory is more useful. Let us consider formation of hydrogen molecule from two hydrogen atoms. ችኛት አሁን እቺ one hydrogen atom ናት፣ እቺ one hydrogen atom ናት። ሁለቱም they have 1s1 electron configuration። እቺና እቺ ሁለቱ approach ሲሆኑ 1s1 እቺ overlap ነው የምትሆነው። overlap ትሆንና እንደነው የሚፈጠረው እንደዚህ አይነት ነው የሚፈጠረው። then covalent bond is formed. Then እዚህ ጋር ምን አለን? the overlapped region ይኖረናል ማለት ነው። that overlapped region is occupied by the pair of the electron ብለናል። the probability where the electron density is high. So እዚህ ጋር overlapped region ናት, then covalent bond is formed. covalent bond is formed. This is how covalent bond is formed in valence bond theory. So electron density is higher in the overlapped region. Yeah, እዚህ ጋር ነው electron density ከፍተኛ የሚሆነው because እዚህ ጋር is occupied by the pair of the electron. Why this overlap? ለምንድነው ይሄ hydrogen እና hydrogen overlap ሲያደርጉ covalent bond የሚፈጠረው ነው? እዚህ ጋር next ጥያቄ because እዚህ ጋር ኔጌቲቭ ኤሌክትሮን አለ፣ ኒውክለስ አለ። There is a repulsive force between electron, nucleus. There is attractive force between nucleus and electron. each electron ወደዚች ኒውክለስ attract ትሆናለች፣ ወደዚችም ኒውክለስ attracted ትሆናለች። እቺም ኒውክለስ ደግሞ እቺን attract ታደርጋለች፣ እቺም electron attract ታደርጋለች። So during the orbital overlap, covalent bond is formed due to the attractive force between the negative electron and the positive nuclei, and due to the attractive force between positive nuclei and the negative electron. This is why the orbital overlap create covalent bond. So the bond is formed due to nucleus electron attraction. Yeah. What about the bond strength of the orbital which are overlapped? እሱን ደግሞ እንዴት አቶሞች ኦርቢታል ኦቨርላፕ ሆኖ ቦንድ ሲፈጠር ቦንድ ስትሬንግዝ እንዴት አፌክትድ ይሆናል የሚል ነው። So here there is a condition of optimal orbital overlap. that leads to maximum bond strength or bond energy at a particular bond length. So for example, greater overlap strong leads a strong bond or stable bond, which means maximum bond energy ያለው result ያደርጋል ማለት ነው። smaller orbital overlap produce weaker or unstable bond, which means the one which has minimum bond energy. So during the orbital overlap, the bond strength is depend on the electron nucleus attraction and nucleus electron attraction. ይሄ ነው። So during the orbital overlap ሁለት አይነት ቦንድ ነው የሚፈጠረው። S&P overlap ሲያደርጉ we two type of bond is produced. አንደኛው ሲግማ ቦንድ ነው፣ ሁለተኛው ደግሞ ፓይ ቦንድ ነው የሚፈጠረው። So ሲግማ ቦንድ እንዴት ነው የሚፈጠረው? ሲግማ ቦንድ during head on overlap, during end to end overlap, during end on overlap or during linear overlap, sigma bond is formed. Specifically, this sigma bond may be produced from SS orbital overlap. It is produced from SP orbital overlap. It is produced from PP orbital overlap. For example, SS orbital overlap, as the sigma bond is produced during SS orbital overlap. During SP orbital overlap, again sigma bond is produced, and during PP orbital overlap, sigma bond is produced. So highest electron density lies along bond axis between the bonded nuclei in sigma bond formation. Okay, ሌላ pi bond እንዴት ይፈጠራል ነው? Pi bond, it is produced sideways of orbital overlap. During sideway or lateral orbital overlap of p orbital, pi bond is produced. So p orbital overlap ሲያደርግ sigma bond produce ያደርጋል or ደግሞ pi bond produce ያደርጋል። ሁለቱንም produce ማድረግ ይችላል። ያ produce የሚያደርገው ግን based on the nature of the overlap of that orbital. For example, if p orbital overlap sideways, pi orbital is produced. End to end ከሆነ ደግሞ end to end p orbitals ደግሞ ምንድነው የሚፈጥረው? sigma bond ነው የሚፈጥረው ማለት ነው። Okay, so SS እና SP ሁሌ it produce sigma, and PP ደግሞ based on the nature of the overlap ነው። lateral ከሆነ end to end ከሆነ ደግሞ sigma ነው produce የሚያደርገው፣ lateral ከሆነ ደግሞ pi ነው produce የሚያደርገው ማለት ነው። So all single bond contains one sigma bond, then double bond ከሆነ one sigma and one pi bond ነው ያለው። triple bond ከሆነ ደግሞ one sigma two pi bond ነው ያለው። ችን ጥያቄ ሞክሩት። determine the sigma and pi bond for the following compound: C2H4, CO2, oxygen, C2H2, nitrogen. Okay, activity 2.22. Which bond is stronger, sigma or pi? Compare the bond strength and length of single bond, double bond, and triple bonds. ችን ጥያቄ እዩት። ካስፈላጊ ከሆነ we can do it. Next, ስለ hybridization ነው የምናወራው። ይሄም it is an imaginary mixing process in which the orbital of an atom rearranges themselves to form new orbitals called hybrid orbitals. ማለት ነው አንድ s እና አንድ p ሚክስ ሲያደርጉ sp orbital sp hybrid orbital ይፈጠራል ነው። 1s እና 1p orbital ሚክስ ስናደርግ 1s እና 1p ሚክስ ሲሆኑ sp hybrid orbital ይፈጠራል። It's a mixing process of orbitals. During the mixing process of orbitals, atoms rearrange themselves to form new orbitals called hybrid orbitals. Here in hybridization, the number of hybrid orbital formed is equivalent with number of atomic orbitals mixed. For example, S እና P mixed ብናደርግ sp hybrid orbital 1s እና 2p mix ስናደርግ ደግሞ sp2 1s እና 3p mix ስናደርግ ደግሞ sp3 hybrid orbital ይፈጠራል ነው። This is a key idea of hybridization. This hybridization may be sp, sp2, sp3, sp3d, sp3d ሊሆን ይችላል። sp ማለት it involves one mixing of one s orbital with one p orbital and forms two equivalent sp hybrid orbitals. In a sp hybridization 50% s character አለ 50% ደግሞ p character ይኖረናል ማለት ነው። molecular geometry of sp linear ነው bond angle 180 ዲግሪ ነው የሚሆነው። so እቺን summarize ስናደርግ ግን sp hybridization central atom is surrounded by two set of electrons ይላል። የማለም ያ two set of electron is central atom. for example beryllium አይደለ እዚህ ጋር chlorine እንደዚህ this central atom is surrounded by two set of electrons. ሁለት set of electron ነው ያለው central atom ላይ። ያ central atom ላይ ያለው set of electron ደግሞ bonding pair ሊሆን ይችላል lone pair ሊሆን ይችላል። ሁለት ከሆነ sp hybrid orbital ነው ብለን ነው የምናልፈው ማለት ነው። sp2 ደግሞ central atom 3 set of electron አለው። በደንብ sp2 ማለት central atom 3 set of electrons አለው። It involves mixing of one s orbital with two p orbitals. s character 33% ነው p character ደግሞ 67% ነው የሚሆነው። molecular geometry of sp2 hybrid orbital is trigonal planar. የቦንድ አንግሉ ደግሞ 120 ነው የሚሆነው። አሁን እቺን ኤግዛምፕል ቦሮን ትራይክሎራይድ እናት there is three set of electrons central atom 1 2 there is no lone pair on central atom so 1 2 3 so hybridization ምንድነው sp2 hybridization ነው የሚሆነው ማለት ነው። the third one is sp3 hybridization. እዚህ ጋር central atom is surrounded by four set of electrons. Central atom is surrounded by four set of electrons. Here there is a bonding pair, there is a lone pair on central atom. Again it involves mixing of one s orbital with 3 p orbitals. Forms 4 equivalent sp3 hybrid orbitals which are equivalent in energies and which are equivalent in shapes. This sp3 hybridization contains 25% of s character, 75% of p character. Example in that. For example here methane and there is no central, there is lone pair on central atom but 1 2 3 4 set of electrons central atom sp3 ማለት ነው። sp3 እቺ በደንብ there is one set of lone pair on central atom so 1 2 3 4 sp3 hybridization ወተር ጋር እንምጣ። here 1 2 there is two set of electrons on central atom so sp3 but here bond angle 109.5 ነው molecular shape tetrahedral ነው። እዚህ ጋር ስንመጣ ግን molecular shape pyramidal ነው bond angle 107 ነው። here እዚህ ጋር ደግሞ molecular shape bent or v shape ነው bond angle ደግሞ 104.5 degree ነው የሚሆነው because of the presence of lone pair on central atom molecular geometry bond angle የተለያየ ነው የሚሆነው ማለት ነው። ግን still three molecules contain sp3 hybridization so more lone pair on central atoms leads smaller bond angle. The third one is sp3d hybridization. Here in this hybridization central atom is surrounded by 5 electrons. አሁን እቺን በደንብ እናያት። አሁን p PCl5 5 set of electron central atom hybridization ምንድነው የሚሆነው sp3d ነው የሚሆነው እዚህ ጋር when one lone pair is present one lone pair አለ ማለት ደግሞ አራቱ ምንድነው ማለት ነው bonding pair ነው still hybridization sp3d ነው የሚሆነው 2 አለ 2 lone pair on central atom አለ ማለት ደግሞ 3 bonding pair አለ ማለት ነው still hybridization ምንድነው ነው sp3d ነው የሚሆነው 3 lone pair አለ ማለት ደግሞ 3 lone pair አለ 2 bonding pair አለ still hybridization sp3d ነው የሚሆነው አገን እዚህ ጋር lone pair እየጨመረ ሲሄድ molecular shape የተለያየ ነው የሚሆነው bond angle የተለያየ ነው የሚሆነው ግን still hybridization sp3d ይሆናል ማለት ነው The last one is about sp3d to hybridization here the central atom is surrounded by 6 electrons yeah 6 electrons and then ሁሉም bonding pair ሊሆን ይችላል ወይ ደግሞ ከ6 ውስጥ and 5 bonding pair ነው 1 lone pair ሊሆን ይችላል ያኔ molecular shape square pyramidal ነው የሚሆነው ግን still hybridization ምንድነው የሚሆነው sp3d2 ነው የሚሆነው ማለት ነው again ሌላ 4 bonding pair ነው lone pair ሊሆን ይችላል still 6 set of electron central atom ነው ያለን molecular shape ሌላ ነው የሚሆነው bond angle ሌላ ነው የሚሆነው ግን still hybridization ምንድነው የሚሆነው sp3d2 ይሆናል 6 set of electron central atom ያለው ማለት ነው thank you very much so የዛሬው ትምህርታችን ይሄ ነው የሚመስለው ቪዲዮ በጣም ጠቃሚ ሆኖ ካገኛችሁ subscribe like እና share ማድረግ እንዳትረሱ next ደግሞ we will start molecular orbital theory ነው ምን ጀምረው ማለት ነው so thank you very much have a nice time